A neural network is a mathematical model or computational model based on the biological neural network. In other words, it's a sort of emulation of biological neural system. It consists of an interconnected group of artificial neurons. Exist more types of neural network, but today we want to explain only two of these. The feed-forward neural networks and the recurrent neural networks. In the first, the information moves to the input node through the hidden node if they exist, and arrived to the output node. In the second, the difference is that the information that, for example, is in a hidden node can go back to the node that stayed before of the actual node. A neural network needs to be configured to give to you the set of desired outputs. We can categorize the learning situation as follows. Associative learning, in which the network is trained by providing it with the input of matching output patterns. These input-output pairs can be provided by an external teacher or by the system which contains the neural network. Or the unsupervised learning, in which an output unit is trained to respond to cluster of patterns with the input. In this paradigm, the system is supposed to discover statistically silent features of the input population. Unlike the supervised learning paradigm, there is no a priori set of categories into which the patterns are to be classified. Rather, the system must develop its own representation of the input stimuli.
On the left, we see one of the simplest feed-forward neural network consists of three layers: an input, hidden, and output layer. Each node in the input layer is a piece of data sample. Hidden layer contains some amount of nodes. Number of nodes is a hyperparameter. These nodes take input, process it with activation function, and send it to output layer, where nodes do the same work, but their product is our estimated result. When you train neural network, you use this result to fix weights and bias. Now, on the right side, we see basic structure of neuron. Bias is a constant which helps the model in a way that it can fit better for the given data. Given a linear combination of inputs and weights, the activation function controls how you pass the information on the next layer. There are a lot of different activation functions. Here are some of them: sigmoid function on the left and rel on the right. Now let's talk about training algorithm. Generally, training process follows next algorithm. While not all samples are correctly classified, take next sample, calculate the output of network and compare it with expecting output. If it's not equal, update weights in network. In code, y minus net of x is an error of classification. Eta is a hyperparameter, learning rate, and w, weight of node. Let's quickly run through the real example of training process. We will work with default classification example. There are 4 datasets. The datasets all have 2 input features and 1 output label. The 2 input features, x1 and x2, are represented by the coordinates. x1 is a horizontal axis and x2 is a vertical axis. The output label is the color of the dots, blue or orange. I use a very simple structure of net, one hidden layer with 1 neuron. As you can see, it works very efficiently. Let's try another example, this circle one. Well, circle dataset doesn't converge on solution with so simple structure. We will set default settings, and we're done. We have solution. You can see the first layer of neurons have simple patterns that detects boundaries. They mostly cut the background in half at various degrees of rotation. Then, as you look to the right, the patterns are more complicated.
So in this first part, we will see the utility and example of uses of neural networks in data mining. Firstly, the utility. For example, vision processing in something a neural network can do, identify objects, classify them. So many things in vision processing, more mainstream Facebook, Google, and others use neural networks to tag your photo, put them in category like picture of flowers, picture of mountains, selfies, etc., etc. Also, for search engines and for targeted marketing, neural networks or learning your habits to be super effective in making you buy stuff. In my second part, we will see a precise case and about the forecasting. Forecasting is required intensively in everyday business decision. For example, sales, the financial allocation between products, the capacity utilization, in economic and monetary policy, in finance and the stock market. More often, forecasting problems are complex. For example, predicting stock prices is a complex problem with a lot of underlying factors, some known, some unseen. So traditional forecasting models throw up limitation in terms of taking into account these complex, nonlinear relationships. The neural networks applied in the right way can provide a robust alternative given its ability to model and extract unseen features and relationships. Also, unlike this traditional model, neural networks doesn't impose any restriction on input and residual distributions. So we can see, to finish, other example, so how to use neural networks. In the classification category, we have in the marketing, where the consumer spending pattern classification, in defense with the radar and sonar image classification, in agriculture and fishing, fruit and catch grading, in medicine, ultrasound and electrocardiogram image classification, medical diagnosis. With about the recognition and identification category, we have general computing and telecommunication with a speech, vision, and writing recognition. In finance, with a signature verification and banknote verification. And to finish with the assessment category, in engineering, with the product, where the product inspection, monitoring, and control, and to finish in security, motion detection, surveillance image analysis, and fingerprint matching.